Yes, my dear students of 10th standard, I welcome you all to revise the remaining part of types of chemical reaction, Unit 10, chemistry portion in your science book. Already we have learned that chemistry means chemical reaction, and these chemical reactions, during the chemical reactions, the atoms are rearranged to form a new molecule, and bond breaking takes place, bond formation takes place. During bond breaking, energy is absorbed. During bond formation, energy is released. Usually we first write the word equation, the equation in the form of words by using their name, the reactant and product. Then afterwards, when you move higher and higher, you have to practice to write using the molecular formula. The reactant and product should be written in the form of molecular formula, and the atoms of the reactants and the atoms of the product always in the equal number. Then only it is going to be a balanced equation. Then already we learn types of chemical reaction. So in the types of chemical reaction, first we learned about combination reaction. Two simple reactants combined to form a product, and decomposition reaction, which is opposite to the combination reaction. One reactant decomposed to give two or more products. For the decomposition, energy is required. This energy is obtained in the form of heat or electricity or photo light energy. Then displacement reaction. The displacement reactions, the element and compound reactants are rearranged, replaced. So normally the most reactive elements replace less reactive element from its compound solution. Then double displacement reaction. Here the interchange of ions takes place between the reactant. This is also called metathesis reaction. Also there are two types: precipitation reaction. If precipitation produced during the reaction, that is called precipitation reaction. Neutralization, normally when an acid reacts with base to form salt and water. This is a simple type of neutralization reaction. Then classification based on the direction of reaction. It is a reversible reaction. So reversible reactions are reactions that can be reversed. That means the product can be converted into reactant. Product can be converted into. Then in case of irreversible reaction, the product cannot be converted into reactant, cannot be reversed. So the reaction takes place only one direction, only in forward direction. And also we have discussed about the differences between reversible and irreversible, and the rate of a chemical reaction. The rate of chemical reaction is nothing but it is a change of concentration of any one of the reactant or product per unit time. The reaction rate is very, very important in case of chemists, those who are designing the process to get good yield of the product, and also in the food processing unit, it is very essential to control the chemical reaction. And next thing, there are 6 factors which influence the rate of chemical reaction. Nature of the reactant, whether it is going to be a organic acid or inorganic acid used in the chemical reaction, Depends upon the reactant, the nature of the reactant, the rate will be changed. Then concentration. Normally, less concentrated reactant produce the product in slower rate. Suppose the reactants are concentrated mean the rate of reaction is faster. Then temperature is one of the important factor which alter the rate of the reaction. When temperature increase, the rate of the reaction also increase. Then pressure. This is also the pressure, increase of pressure is directly proportional to the increase of the reaction rate. And catalyst, this is a substance which is used to alter the rate of a chemical reaction, and this substance will not take part in the chemical reaction. Normally in your book it is given manganese dioxide and potassium chloride on heating decomposed to give potassium chloride and oxygen but at slower rate. But when the addition of manganese dioxide, the rate of the reaction is faster. Then surface area, that the powdered form of the reactants, the minute particle form of the reactant give more surface area for the reactant to react. So the collisions of the reactant particle take place fastly. So the rate of the reaction is increased. Now we are going to study about the state of equilibrium. So what is called a state of equilibrium? See, it is nothing but it is a state of balance, or it is a stable situation. Opposing forces cancel each other out and where no changes are occurring. So the opposing forces are cancelled, there will be no furthermore changes take place in the reactant product. That stage is called the equilibrium state. So it is given saying, in a reversible reaction, both forward and backward reaction take place simultaneously. So this equilibrium attained only in the reversible reaction only, not in the forward reaction. Not only the forward reaction, only take place in the reversible reaction. So when the rate of forward reaction becomes equal to the rate of backward reaction, then no more product will be formed. This stage is called the equilibrium state. Actually, this stage, no net change in the reaction. That means the reactants and the products are in the stage of without change. There will be no changes in the product and reactant. And see, since the equilibrium is attained in a chemical reaction, that is called chemical equilibrium, because this is take place in the chemical reaction. So it is called chemical equilibrium. So there is a definition what is called chemical equilibrium. It is a state of reversible chemical reaction. You have to understand this equilibrium attained only in the reversible chemical reaction, in which no change in the amount of reactant and product. So at the stage of equilibrium, the amount of reactant and the amount of product will be in equal rate. There will be no more changes. So that's why it is given, see, rate of forward reaction is equal to rate of backward reaction at the equilibrium state. Then a simple explanation is given. See, initially the rate of forward reaction is greater. Normally when the reactant combine, they combine at faster rate to give the product. That is the forward reaction is faster at initial state than the backward reaction. However, during the course of reaction, the concentration of the reactant decreases and the concentration of the product increases. So Initially, the rate of forward reaction is faster, then slowly the rate of forward reaction decrease and rate of backward reaction, that is uh, the formation of product will be more. So the concentration of the reactant decrease and the concentration of the product increase. Since the rate of the reaction is directly proportional to the concentration. So the rate of forward reaction decreases with time, the rate of backward reaction increases. This already we have learned in the previous case. See, and the rate of reaction definition, this is the amount or concentration, the change of amount or concentration of any one of the reaction or product. So it is going to see A gives B. So rate minus it is given. That means see that the negative sign increase indicate the decrease of concentration of the reactant. The decrease of concentration of the reactant. And see what happens, see, then the plus sign indicate the increase of concentration of the product, and this will be equal at one stage, that is called a chemical equilibrium. Now see here, at certain stage both the rates become equal, so that is the forward reaction, backward reaction, both are an equal status at one stage. From this point onwards, there will be no change in concentration. So the reactant concentration will be remain same. The product concentration will be remain same. There will be no change of concentration at one stage. That state is called equilibrium state. So you have to simply understand, initially the forward reaction is greater and backward reaction is slower, but after some time what takes place, the forward reaction will be decrease, backward reaction will be increase. But at one stage both the rate, forward reaction, backward reaction become equal, and that stage there will be no change in the concentration of the reactant and product. This stage is called equilibrium state or equilibrium state. Now consider one decomposition of calcium carbonate. Calcium carbonate is lime, that is going to be a marble chips, slag lime and chalk, different forms. So on decomposition, on heating calcium carbonate, what takes place? Calcium carbonate decomposed into calcium oxide and carbon dioxide. Calcium carbonate is solid, calcium oxide will be formed also solid, and carbon dioxide is gas. Normally this carbon dioxide is going to take place and it's going to be evolved out, it's going to be released out. Suppose the reaction takes place in the open form, open vessel, in the open test tube. So the calcium carbonate decomposed calcium oxide and carbon dioxide. Carbon dioxide immediately comes out, releases out. And see, at that stage there will be no reversible reaction will take place, because the product should not evolve out for the reversible reaction to attain the equilibrium. So if the reaction is carried out in closed vessel, only in closed vessel, it is going to reach a chemical equilibrium. So the rate of decomposition of calcium carbonate is equal to the combination of calcium oxide and carbon dioxide. And see, this reaction take place, and normally this equilibrium stage is obtained when the reaction takes place in a closed vessel, the closed container. Otherwise the gaseous product will be evolved out and there will be no backward reaction, no equilibrium will be obtained. Then not only chemical reaction, in physical changes also equilibrium is formed. For example, when the water kept in a closed vessel, it evaporates. And the evaporate water is uh, going to be condensed to form that water vapor and water. No water vapor escapes out of the container as the process takes place in a closed vessel. Suppose the water vapor is take place in the open container, open vessel, the water vapor releases out. So if it is take place in the closed vessel, what I can see, the vapor form a pressure at one time, the vapor condenses to form again liquid. So water to water vapor, that is forward reaction, then water vapor to water, that is backward reaction. So the rate of formation of vapor, the rate of condensation of water, all is going to attain equilibrium at one state. That is, the volume of liquid and gaseous phase both are in the constant state. That means there will be no change in the concentration of the reactant product. This is called a physical equilibrium. So physical equilibrium is a state of physical change at which volume of all the phases remain unchanged. That means the volume of water and the volume of water vapor will be remain same. So volume of a liquid form of water, the volume of gaseous water vapor will be in same rate. That is called a physical equilibrium. Then next see, so here on diagram is given, which is going to explain the state of physical equilibrium of water. So initially see, the water is converted into water vapor. So forward reaction is faster. Then in the intermediate state, what happens? See, water into water vapor. The water vapor again slowly try to condense into water. Then in the equilibrium state, the formation of water into water vapor, then water vapor into water, both are remain unchanged, remain static. So this is called equilibrium state of water. This is a physical equilibrium of water. Then characteristics of equilibrium. What are the important properties? The chemical equilibrium, the rate of forward reaction is equal to backward reaction, and there will be no change in the concentration, pressure, color, density during the equilibrium state. Then the chemical equilibrium is a dynamic, that is a stable balancing between the continuing process of forward and backward reaction. So chemical equilibrium is a dynamic because both forward and backward reaction continue to occur even though it appears static externally. So outwardly it see there will be a static position, but inwardly the reaction take place in this stable condition, in this stable balanced process will be there. That is called a dynamic equilibrium. Then in physical equilibrium, the volume of all phases remain constant. That is the volume of water is equal to volume of gaseous water vapor. Then in aerated soft drinks, that is a soda water, carbonated water, see what happens? See, the carbon dioxide is dissolved in water using applying pressure. See, the dissolved carbon dioxide and gaseous carbon dioxides are in equilibrium in the that is in the soda bottle, in the aerated water bottle. That is the dissolved carbon dioxide, gaseous carbon dioxide, equilibrium. When we open the bottle open, the gaseous carbon dioxide try to escape, but the dissolved carbon dioxide begin and dissolve back to the gas phase, trying to replace the gas that was lost when we open. That's why if you leave the bottle open condition for a long time, it will goes flat. because of the evolution of carbon dioxide. The carbon dioxide will be releases out, blown away in the air. Then next to see ionic product of water. So this is based on ionization. Ionization. What is called ionization? So ionization is simple. Already you have learned in 9th standard. This is the dissociation of a molecule into ions. So this is based on the ionic product based on ionization, the dissociation of molecule into ion. So in the ionization, it is a process of loss or gain of electron by an atom. And normally see the electrically neutral atom or molecule are converted into electrically charged particle. So during this ionization, what takes place is the electrically neutral atom, so water H2O, that is a electrically neutral molecule, neutral water molecule. So by passing electric current, what takes place is the neutral water molecule dissociate into ions, dissociates into ion, H plus ion, OH minus ion. The dissociation take place. So and the pure water is insulator, non-conductor of electricity. Already we have learned pure water will not conduct electricity, but acidified water will conduct electricity. So but the precise measurements show that pure water also conduct electricity very little extent, at small scale it conduct electricity. This conduction of electricity is because of the self-ionization of water. Self-ionization. So ionization is what? Ionization is the dissociation of molecule into ion, dissociation of water molecule into charged particle. So here it is given the self-ionization or auto-ionization is a reaction in which two like molecules react to give ions. This is the definition. Self-ionization or auto-ionization is a reaction in which two like molecules. That means you take a two water molecule. So these two water molecule going to react with one another. See H2O plus H2O. So they say here in the process of ionization of water, a proton from one water molecule transferred to another water molecule leaving OH ions. So proton is dissolved water forming hydronium ion. See H2O liquid, H2O liquid. These are the reactive water molecule. So in the first H2O in the form of liquid, that H2O dissociate into H plus and OH minus. This H2O dissociate into H plus and OH minus. And this H plus combine with H2O. This H plus combine with H2O reactant to give H3O plus hydronium ion. H3O plus hydronium ion leaving OH minus. So two charged particles are formed, cation and anion. The same reaction is given in the balanced form. 2H2O gives hydronium ion and hydroxyl ion. So the hydronium ion is a strong acid, hydroxyl ion is strong base. So when they formed, immediately they react again to form water. So these reactants of hydronium ion, hydroxyl ion, because of their strong acidic and basic nature, they immediately recombine to produce the water molecule. So it is a reversible reaction and it going to attain equilibrium very quickly. So the extent of ionization is very little and the concentration of the ion produced also very less, because dissociation take place to give the products of hydronium ion and hydroxyl ion. Immediately this hydronium ion and hydroxyl ion recombine to form the water. The product of concentration of the hydronium and hydroxyl, these are called a ionic product of water. The concentration of hydronium ion, hydronium in H3O plus, hydroxyl OH minus. So this concentration is ionic product of water. This is always represented by the symbol Kw. K means ionic product to water W. It is mathematically expressed ionic product of water, that is what are the ions form? Hydronium ion and hydroxyl ion. Hydronium ion formula H3O plus, hydroxyl OH minus. So this hydronium ion is obtained from the H plus ion. Usually from the H plus, when water molecule decompose, it going to give H plus and the OH minus. And see, this H plus is same as H3O plus, because this H3O plus is obtained from H plus, so we can write instead of H3O plus, H plus can be written, that is ionic product of water. H plus cation, hydrogen ion, OH minus, hydroxyl ion. These are the ionic product of water, and its unit is mole square decimeter power minus 6. At 25 degrees Celsius, its value is 1.00 10 power minus 14. 10 power minus 14. The next is see pH scale. That pH is a power of hydrogen ion concentration, that we will see in the next class. So what do we have revised now? See, that is the equilibrium. That is nothing but it is a state of forward reaction become equal to the backward reaction. It is the state of reversible chemical reaction in which no change in the amount of reactant product at this stage is called the chemical equilibrium. And also chemical equilibrium state, because there will be no change in the concentration of the reactant product, no change in the concentration of the reaction product. That state is equilibrium state. That equilibrium is obtained only when the reactions are carried out in a closed vessel. And not only the equilibrium in chemical reaction, also this is take place in physical changes also, that is called the physical equilibrium. That is, for example, the formation of water to water vapor, then water vapor to water is obtained when it is take place in a closed vessel. Then characteristics and rate of backward and forward reactions are equal. There will be no change in the pressure, color, density, viscosity at the equilibrium state, and it is a dynamic equilibrium. And in physical equilibrium, the volume of the reactant and product remain constant. The phases, that is liquid and gas, will be constant. Then ionic product of water. This is because of the dissociation of molecule into ions. Molecule into ions. The water decomposed into H plus and the OH minus. The H plus combined to water molecule to form hydronium ion and OH minus ion. And hydronium ion is a strong acid and hydroxyl is a strong base. So immediately they recombine to give water molecule, and equilibrium is quickly attained. This is called ionic product of water, H plus and OH minus. So revise all the things and prepare the solution lesson for test. You will be given test. I will intimate the test time and date. So prepare well. Prepare all the objectives. Prepare this lesson also, and complete your classwork. You will be called to submit the classwork after 2 or 3 days. So get ready with your classwork and also prepare well. Don't waste the time. Thank you. God bless you.